Hello students, welcome to this class of fluid mechanics. Today's topic is vortex flow. We will study about vortex flow. What is vortex flow? First of all, it is a flow of fluid along a curved path, right? Or we can say or flow of rotating mass of fluid. Flow of rotating mass of fluid, right? These terms are important here. Here is curved path and rotating mass. Please keep in mind here that it's quite different from rotational flow, right? We have studied earlier rotational flow, which is a very different thing. This is rotational flow is not a vortex flow. What happens in rotational flow? In rotational flow, each fluid particle revolves around its own axis, right? In rotational flow, each particle is rotating around its own axis. But in vortex flow, the whole mass fluid flows in a curved path. Getting my point? It's not that individual particle is revolving around its own axis. It's the whole fluid as a mass flows in a circular path, right? Like in rotational flow, we had omega x, omega y, omega z. Remember, these were the components of rotation, right? But there is no such thing like this in vortex flow. Fine. So now let's study further. Vortex flow is basically of two types. Okay, there are two types of vortex flow. First one is forced vortex flow. And second one is free vortex flow. Right? So we will see what is forced vortex flow and what is free vortex flow. First of all, let's study about forced vortex flow. Right? What is forced vortex flow? As the name suggests here, one is forced, another is free. Forced vortex is a flow where some external torque is required, right? In forced vortex flow, external torque is required for the flow to rotate the fluid mass. We need a certain external torque. In this case, fluid mass rotates at constant velocity, right? Fluid mass rotates at constant velocity. That is omega. Actually, you can write here angular velocity. Fine. This is the angular velocity, right? The fluid mass is moving along a curved path. So here in forced vortex flow, fluid mass rotates at constant angular velocity because we are applying a certain external torque on it. So what is tangential velocity? We know that omega is constant. What is the tangential velocity of fluid particle? Tangential velocity of fluid particle. What it will be? V is equal to R omega, right? So this is the equation of vortex flow. Equation of forced vortex flow. V is equal to R omega, right? Let's say this is this. Okay. And here from the center, let's say this distance is r and my flow is in, my angular velocity is omega. So what is v? Tangential velocity is v is equal to r omega. Fine, it's quite simple. So this was my forced vortex flow. Now what are some examples of forced vortex flow? It's like in, let's say we can say impeller, right? Impeller of centrifugal pump. Impeller of centrifugal pump. Fine. Or runner of turbine. Runner of turbine. Or as we see in mixer grinder, very common example. Mixer grinder at homes, you can see here the flow is forced vortex flow. You see the chunk move inside the mixer in a curved path. Mixer grinder, right? Or washing machine. Washing machine, right? These are all the examples of forced vortex flow. So now let's study about free vortex flow, right? Let's study about free vortex flow. So what is free vortex flow? As the name suggests, here is no external force. No external force, okay? Or torque, you can say. No external force or torque is acting on the rotating fluid. That is called a, even then if the fluid is rotating in a curved path, moving in a curved path, then the flow is called a free vortex flow, because it ain't required external force. External stimulus is not required for that flow to happen. So that flow is called a free vortex flow. So it means why it will rotate? It must rotate due to natural phenomena. Due to natural phenomena. We will see the examples, you will get what I am saying. Right. So first of all, if there is no torque acting on the fluid, then its angular momentum must remain constant. If torque is equal to 0, it implies angular momentum is equal to 0, right? Which also implies that rate of change of angular momentum will be equal to, sorry, there was a mistake. Yeah. Its angular momentum will not be equal to 0 if torque is 0, but it means rate of angular momentum will be 0, right? Rate of angular momentum will be equal to 0, right? It's basically a Newton's second law. That's with respect to force. Similarly, we can derive for the torque. Torque is equal to rate of change of angular momentum. So if my torque is 0, it implies rate of change of angular momentum is also 0. So which also implies that if I denote my angular momentum by L, dl by dt is equal to 0, or we can say L is equal to constant. That is, my angular momentum is constant. What is angular momentum? mvr, right? R is radius, v is velocity, mv is mass. Which also implies that mvr is equal to constant, right? Now mass is a constant quantity, so we can say Vr is equal to constant. This is my equation for free vortex flow. Equation for free vortex flow. Fine, Vr is equal to constant. For forced vortex flow, it was V is equal to R omega. For free vortex flow, it's Vr is equal to constant. Now what are its examples? Let's say it's like you must have seen wash basin sink, right? Flow through wash basin sink. You know, when there is a lot of water, when the sink is completely filled with water, let's say there is some blockage, then when you remove the blockage, the flow revolves in a, the flow is in a curved path, right? That flow that you see, we are not applying any external torque there, but it is due to natural pressure difference is such a way, is in such a way that the flow is a curved flow. That is called a free vortex flow, right? So it's a wash basin sink. Another example is flow around circular band of pipe. Flow around circular band of pipe. Fine. Or there is a whirlpool. Whirlpool in river. Whirlpool in river. Or we can say flow through casing of centrifugal pump. Flow through casing of centrifugal pump, right? So these were some examples of free vortex flow. Okay, I hope you are clear with vortex flow. We have studied both the types, forced vortex flow and free vortex flow. If you have any doubt, please put it in comment section. We will meet in next class. Bye bye.